Welcome back to my channel. I'm Brian Kafaki, and as usual, I'm drinking with different mugs. Today's mug is University of Rochester because one, I love the mug. It was given to me by my daughter who just graduated from the university, so pretty cool. And I'm excited about this topic. We're going to be talking about Postgres. This is an introduction to PostgreSQL or Postgres. Those are usually the two ways it's pronounced, and if you're wondering, I had to look this up because I've worked with it, but I've never actually heard many people say it other than the traditional Postgres. So we'll talk about that. And what is Postgres? We're going to learn about how Postgres is a really robust, free enterprise data management system. So let's jump in. By the way, took some time, left Microsoft a little over a year ago to write a book called Master Azure Databricks. Check it out. It's basically Databricks is a wrapper around Apache Spark, which is the most popular big data and analytics platform, open source I should say, big data analytics platform. Very popular, works with Python and R and Scala, very robust. And it also covers about 80 to 90% of it is just generally applicable to Apache Spark. So even if that's what you're focused on, you'll learn a lot about that because I get into how to use it with all these languages. It's comprehensive, takes you step by step through a use case. So you get a feel of what it would be like to do this in a job. The company asks you to do a project, and it takes you all the way from the earliest stages through exploratory data analysis to machine learning features to data engineering with all the different tools like Python, R, etc. And it's a lot of step-by-step use cases with examples. It's available on Amazon. It is not available in a PDF. If I gave it to a PDF, there would be no point in selling it because it would be free, so it's not available in a PDF. But you can get a Kindle reader on any device you can think of, so you can get it, use it. And the print book I may put out, but it's a lot of pages. As I mentioned, it's very in-depth, so it's going to be a pretty hefty book when it's printed. So I recommend the ebook edition. So where are we going in this discussion? I'm going to talk about what is Postgres, what are its strengths, what are its weaknesses. We'll talk about use cases. So let's step back in the Wayback Machine. I've actually used Postgres extensively, and I'm choosing the pronunciation Postgres, ignoring the QL. I'm going to consider them silent, so I think it's just easier to say. But my experience was, one day, oops, this came up in the wrong order. One day I got an IM message from somebody, a friend, and he said, "Are you open to doing a PostgreSQL contract?" I guess I jumped between these, sorry. And I had never even really heard much about Postgres before this. So I said, hang on. And I Googled it, looked it up, and said, I said, wait, I'm busy. I'll call you. I'll get back to you. I downloaded Postgres. I found it was available on Windows. I work on Windows. I'm like, great, okay. It's open source. I decided to say, before I said no, and honestly, I was going to say no because I thought, well, I don't know anything about Postgres. I downloaded it, installed it, and I was surprised how easy it was to install and start using. And it came with something called pgAgent, which was really quick to set up. And I was able to use that. It's not much different than SSMS, and I'll do a demo at the end. Very similar to SQL Server Management Studio with SQL Server, which I'm very familiar with. And I thought, wow, this is pretty easy. I looked at the SQL code. I looked at some examples online. I'm like, this really doesn't look much different than Oracle or SQL Server. So I'm like, sure. So, and if you're a consultant, you've got to be ready to say sure, without always knowing all the details of something, because sometimes the opportunity comes. And this was a great opportunity to learn as well. And as I mentioned, it is very intuitive if you've got experience with something like SQL Server or Oracle, even something like DB2. So it's good to know that. It's very powerful features. I was surprised, it's performant. I was not expecting that. I thought it was going to be like this lightweight toy database. It's not. It's powerful. It is enterprise. And it's competitive. I was surprised, things that I thought were really slick and cool in SQL Server were available in Postgres. Some of them even longer than they were available in SQL Server, so shocked for me. So let's talk about what is Postgres. It's free and open source, and it's an enterprise data management. Now, what do I mean by enterprise data management? Sounds very important, right? Well, there are things like SQLite, which are client databases, and they're great. Microsoft Access is like that too, right? It's great for a sort of local, persistent, but it's not meant to be like lots of users banging away. Certainly wouldn't want to be something that your business is relying on for transaction processes. I can't imagine Amazon relying on SQLite, banging away against the database for people's orders. So when you think about something that is heavy duty, it's got to be resilient, it has to be available 24/7 in many cases. That's what I mean by enterprise data management. And it has to perform really well. And the beautiful thing about the free and open source means it's really open source. I'll mention later somewhere in here, but Amazon has adopted Postgres and they use it in their products and they just can use it commercially. They're charging people for it as a service, and Postgres isn't asking for kickbacks or anything. I don't think there's any money. That's part of the use. You can use it in commercial installations and services, which is really good. So basically it's free and clear. Do what you want with it. There's a license thing you've got to look at. I'm sure there's certain restrictions and nomenclature, but generally just use it as you like. It does perform really well, and that was really impressive to me. I'll talk more about that. And it supports really large databases. That's where its kind of origins are. It was designed for big databases, not toy databases. And as I mentioned, the features it offers are competitive with Oracle and SQL Server. Things that I would never have thought, that this open source free database would have are really there. Resilience and high availability are also at the heart of it. Again, if you think about always on and things that you typically think of like, that's why I use SQL Server, you actually can get that with Postgres as well. And these are some companies, I got online a list, that use it. I mean, Apple, Skype, Netflix, Twitter, Apple's, YouTube, Spotify. I mean, these are big companies. These are not toy companies, right? And they use Postgres. And as I mentioned, I couldn't remember the name. Amazon Redshift is actually built on Postgres. So if Amazon chose this as the database, they didn't choose MySQL, they chose Postgres to be something they could adopt and use like this. It's pretty impressive. And under the covers, there's other places they also use Postgres as a PaaS service for a database. I'll talk more about that as well a little bit, but that's available. Postgres is available as a PaaS database, meaning platform as a service. It does everything for you. Available on Amazon, Google, and Azure. So pretty cool. So let's talk a little bit more about the strengths. I am very critical. I will try to show you the bad side of Postgres. There are always weaknesses in anything, and I will cover that as well. Number one, it runs on many platforms. Now this is really kind of cool and interesting because if you think of Oracle, I think of Oracle as being a Linux or Unix environment database. I don't even know if it runs on Windows, to be honest, but I've certainly never thought about trying to run Oracle on Windows. And although SQL Server in recent years, as of 2017, released a Linux runnable installable version, it's actually using containers. Everything I've seen says that SQL Server running on Linux is really a containerized version of SQL Server. So it's not natively running, though it does perform well, and they've got all kinds of great metrics. And that's it, though. It doesn't run on Mac OS. It doesn't necessarily run on all different versions of Linux. But Postgres runs on many platforms, so that's pretty cool. And so that I thought was really impressive. In fact, as I mentioned, I just grabbed it, installed it, and said, wow, I'm good to go. And I was surprised how easy it was to do that. It scales well. So you might be surprised. You might say, well, I don't know, I got 10 terabytes, I got 50 terabytes. And it scales well. I'd say about as well as you would expect its commercial competitors to scale. It has some unique things. One of the things I like is it's a very extensible environment. So Postgres was designed to be like plug and play. You can just add extensions. And you'll see a lot of things. You may say, gee, I wish it could do, better JSON file handling. And they'll be, oh, there's a JSON extension I can install. There's a lot of different extensions. So you may find things. And I was, in my contract, I had to add some extensions that were supporting, at the time, they didn't have the best windowing type of functions. So I was installing extensions to help with those types of things. Now they've built it in. So the last releases have been really impressive with what they've added. It also supports multiple programming languages. Now, typically you'll see, Oracle has their PL/SQL, I believe. PL/SQL, I think they call it. And SQL Server has T-SQL. And so Postgres has their pgSQL, but they also support Python. You can use R, you can use TCL, you can use a number of different languages. Now, I'll talk about that. There can be security risks depending on the language that you enable and how you use it. But it does support a number of different languages. The most important, though, is still going to be the SQL language. I think that's primarily what I would focus on. And it comes with a powerful integrated development environment called PgAdmin. And that also impressed me because back in the day, I used to work with Oracle, and this was a long time ago, admittedly, and they had no decent IDE to work with. So this was impressive to me. So again, runs on Windows, Linux, Mac OS, and all the public cloud environments. Not only does it run there, but it has a PaaS version, which is, again, really cool because I think there's a lot of advantages to using Postgres as a PaaS. Most importantly, when you use a commercial database, whether it's PaaS or as a VM type of product, you're paying licensing fees, even if you're on Azure. So if you want to run Azure SQL Database, a big part, probably the majority of the cost, is actually coming from the licensing cost, because they're not going to give you that free. If you could go on Azure and use SQL Database and only pay for your compute costs, nobody would be using the SQL Server on-premise because of the expensive licensing cost. This would be a no-brainer. Just go to Azure and get it for free. So because of that, you're going to pay. And of course, if Azure were to run Oracle, they're going to have to charge you for the Oracle licenses because they can't give it to you for free. So this is a big win. Take it from me. Key features. Let's talk a little bit more about the riveting features here. There's extensive JSON support, which I like. There's some extra features in there that they've added pretty recently, so you can manipulate and work with JSON files, which, as we know, is very trendy these days. It's the new XML. It also supports partitions. Now, when I worked on the contract that I was doing, it only had what's called table inheritance, which is a really cool way to get the equivalent of partitions. What you really do is it's based on object-oriented persistence, is where they started from. And so you say, I'm creating a table, and you create another table which inherits that table, and that child table gets all the columns and everything from the parent table, but it can also exist as a separate table. And what that means is you can have the parent table as a way to sort of consider that a master view or a host for all of the partitions, or you can access any of the individual child tables, which is like accessing one of the partitions. The beauty of it is it's really simple to implement. It's pretty elegant. And personally, managing partitions, I'm not a big fan of. It's kind of a pain to do. I've done it in SQL Server, and it's kind of difficult. There's a lot of tasks and things you have to implement to get it to work correctly, and then you have to be able to delete and merge partitions and things. So I prefer simple solutions over that, but it does support it. I think the Postgres implementations of partitions looks a lot easier to use than what I've seen in SQL Server, because they've kind of seen the problems there and made it easier. So I like that. Now, when I worked with it, it only supported functions. Now, this isn't functions as you may think of SQL Server. This is more like, think of the C language. The C language only uses functions. Why would you not use functions for everything? You do anything you want, and at the end you can return a code saying true or false, like this was successful, or if you want to return a value, you can do that. So functions could do anything, can do anything in C. In a similar way, functions can do anything in PostgreSQL. Great. But sometimes you're migrating from other platforms, and Postgres is more and more becoming aware. You may want to come to this from SQL Server or Oracle or MySQL. So they've implemented stored procedures. I want to say more as a sort of syntactic sugar and for convenience if you're migrating code. So you can say create or alter stored procedures. You can do the same things. If you want to return values in stored procedures, you use what they call input, output parameters, return values. Functions can return values. So I don't really see a big difference. Choose what you like. But they now support that, and they didn't that long ago. The other thing I always look for in a database, especially if you're doing any kind of data warehousing, is you need a job scheduler. This is something most places overlook, even in Azure and different web environments, the cloud services. There's not many great answers to job scheduling, but it's a critical feature when you're doing anything with data. You need to be able to schedule your ETL jobs to run overnight or different times. When data files are dropped into storage, you may want to pick them up and load them, and on and on. So it's important to have a job scheduler. And in Azure, what I tend to favor the most is Azure Automation. But pgAgent is similar to what SQL Server has, which is called SQL Agent, and it does a very similar function. Now, to be honest, SQL Agent is a much nicer, easier to use service, but pgAgent does the job. You can schedule things, you can run SQL tasks like stored procedures and things to do work, or you can run like external scripts and things. So you get what you want, enough to do what I was doing. I was able to get the equivalent functionality I needed. Security features, when I did this was a few years ago, probably like 5 years ago to be honest, when I was doing that contract, and the security was really lacking in many ways. They've added a lot of improved functionality, and I was really impressed recently, kind of reading and updating myself on what have they done. So now they even have row and column level security. They have a much better encryption for passwords internally. So they've added a lot of good features. I'm going to talk more about security. In my books, it's better, but security is probably not Postgres' best story, and I'll talk a little bit more about that, compared to especially something like SQL Server, which just has security everywhere, right? It's a very secure database. It also allows you to get to data externally. This is another thing that's really important for any kind of ETL work, which is what I do a lot of. Flat files, other databases. Now, my particular contract, there's a big no-no. Don't do this. That worst practice, which is they coupled the production database, Postgres, with the, in the same instance, mind you, with the data warehouse database. And this created a version coupling and a lot of dependencies because they just used backups and restores between them to get data from one to the other. And it was a huge problem for me because I wanted to take advantage of new features, but I couldn't upgrade the data warehouse Postgres database because the production one was on the same version and it was locked in lockstep. I couldn't do one without the other, which is why it's a bad idea to do that. Instead, I split off a new Postgres database instance and I was able to upgrade that, and now I'm independent of what production does. Because obviously production, you have to be very careful when you start upgrading versions. But a data warehouse, you can explore and test and then switch over. So we did. So to get to data, I used foreign data wrappers or foreign data access features, and that allowed me to define data in the production Postgres instance that I could read and retrieve data from. In SQL Server, they call these link servers. It's implemented differently, but the functionality is pretty much the same. You define external data, and you can get at it. It's more work, to be honest, in Postgres because you can't just define the connection and then query any table you want. Any table you want to access, you need to define a table definition just like it was local. And then Postgres creates a connection between the two, and they have to be kept in sync. So, a little bit of work, but it worked, and I was able to do my ETL process from production to the dev instance, or data warehouse. It also supports high availability, load balancing, and replication. Now these are big hot buzzwords with DBAs, understandably. High availability. Typically, enterprise databases need to be on. Any downtime is a lot of money, typically for the company, and everybody gets upset. DBAs typically worry about the online transaction processing and making sure everything's always running. That's what they get paid for, and that's where they get into a lot of trouble if it doesn't happen. So high availability is key, and there's ways to do that, all kinds of things I'm going to talk a little bit more about. Load balancing is when you can put multiple machines in use, and when one gets overloaded, another one can kick in and they can kind of share the workload. And of course, replication is a way to provide a sort of high availability in some cases, but it's also a way to push data from one environment to another. For instance, you may want to push data over to replication to be used in a data warehouse environment or something, so you're not keeping it on the production server. So these are really important features. Oh, and I also want to mention that for geospatial support, there's an interesting separate but integratable service called PostGIS, which is Postgres's geospatial product. It's kind of a separate product that is focused specifically on any kind of latitude, longitude kind of spatial analysis. So it's pretty cool, free again. And I want to call out, because one of the reasons why I'm really excited, particularly these days, is that Postgres seems to be the de facto database of choice of Python. And I think that is one of the reasons it's getting a lot of attention now. If you were going to pick, the only database built into Python, and I talk a lot about, is SQLite, but if you're going to pick a commercial database, a scalable big database for enterprise, Python has chosen Postgres, it seems like from the beginning. And it's just many examples. There's a driver for it that you can just install in the pip command, you're done. And much of the things like pandas and everything even has things that really integrate nicely with Postgres. If you were to go with Django and you say, I'm going to use Django, which is a web development framework for Python, really awesome, I love it. It also tends to, by default, use Postgres. It's kind of the assumed standard. Let's just use Postgres. So there's an interesting sort of friendship, if you will, and collaborative sort of space between Python and Postgres, and it just seems to be sort of the default that you can use. If you ever want to use Python with Postgres, it's a piece of cake. You can do it with other databases. I talk about that in my videos, but Postgres is just so easy that why not? Also has, this is just a picture of PgAdmin, which is sort of like SQL Server Management Studio or whatever IDE DBAs use, but also ETL developers and database developers use. And you can see here, it shows you what databases there are. It has a sort of folder structure, much like SQL Server Management Studio. Here it shows you what's going on in the database, so monitoring and stuff. And I like to show this because I was surprised, like, wow, this is kind of like monitoring SQL Server, right? You can see what's going on. So again, there's a lot of functionality here that surprisingly familiar and just like, wow, I like it. And free is a really good price, so you can't argue with that. And along those lines, let's talk about cost. Now, I'm going to tell you a story. Wasn't that long ago. I went for a job interview, and this was a vice president of engineering in this company. And mind you, they were strong with SQL Server, and they asked me a question. They said, so, if you had a choice and I asked you, what database should I use, what would you say? And I surprised them because I said, it depends. I've been thinking actually a lot about this because these are the kind of things I think about at night. And I thought, well, if I were a small mom and pop shop, or if I were a startup, or something where I don't have deep pockets, I don't have a lot of money, and I have to really watch costs, I would probably go with Postgres because it's very rich in functionality. It has always on availability. It's rich. I can use as many instances as I want, whenever I want. I don't have to worry ever about paying licensing fees. And it's particularly good as I scale up my new product, whatever, I never have to worry about those fees. They're just not there. I've got this great database for free. So I thought that would be a good choice. Did not get an offer. They did not like that answer. He did not like that answer at all. And he kind of tore into me about that. But I was giving him an honest answer. There are different database solutions are for different purposes. Postgres wouldn't be there if it didn't serve a need. And I'm going to talk about those needs after this. But I want to talk about cost because this is something that can really be lost in the shuffle and something that I'm very aware of. I worked at Microsoft. I saw these things close up. So the first thing to understand about Postgres is it's free. I mean really free. So you may say, I need 1 instance. I need 10 instances. I need 100 instances. I want always on. So you can imagine you might have 100 instances, 1,000 instances of Postgres going. It's all free. You can decide to do what Amazon's done. I want to wrap production, commercial solutions around Postgres and charge people for it. Apparently that's free too. And you can see it actually in their licensing. They say if you want to use it for commercial use, that's okay. That's very powerful. I mean, obviously Amazon's not dumb. That's a really good thing. And they must have thought Postgres was a good solution to be able to pick that one. What you need to understand about commercial database solutions like Oracle and SQL Server is you never buy them. You never own them. You rent them. This is like renting your apartment or paying for electricity, however you want to see it. But you're renting or paying for the service. And even when you think, I've installed it on premises, I bought SQL Server, I'm done, you didn't really do that. What you did is you got an agreement to use their service within constraints. All right, and those constraints, they charge you for, and if you go beyond those constraints, not a problem, but they'll charge you more. So let's take a look at those. License costs add up quickly. Let me look at some specifics. First of all, you may assume that if you're doing QA or performance testing or dev environments, there's no way you have to worry about costs. Microsoft, for instance, offers, and I don't mean to keep hitting on Microsoft, it's just the product I know better. Oracle, I'm sure, has all the same things. But Microsoft has a development edition of SQL Server, which is free, it's great for learning, it's great, and that's what its intention is. Play around, learn, explore, but it's not meant for production use. Now you have to be really careful there because if you pull in a copy of production data into a SQL Server instance, whether or not it's development edition, you may be liable for cost there. They could potentially assess you for charges. It's up to them. And they do audits. They can come in and check things and do audits, etc. So be careful there. If you're doing performance testing, you may very well be running production workloads and doing things, and you have to be careful to not violate those licensing agreements lest you get charged for it. So you do have to be careful there. Maybe you've got a dev instance or a QA instance and you decided, I don't want to set this up in production. I just want to do some sort of little ETL work, which I'm then going to push into production. You're starting to cross a line there where you can get into, again, licensing issues. So be careful. Now this is a big one, failover clusters. When DBAs talk, this is a really hot thing among enterprise data warehouses. The idea is you've got this database. Maybe you've got 2 servers that are sharing a workload, and it's heavy duty and it's critical to the production of the company. It's a lot of money there and risk, right? Well, what do you do to avoid the risk? For instance, what if they fail? What if something goes down? You could be down for hours, if not days, if something failed. So what you do is you create redundancy. You create multiple servers to cover as backups. Now the question comes into, let's take a look here. Imagine something like this, and this I got off Microsoft's site. The link is right there. But imagine something like this where you've got all these machines, and I'm not going to get into the architecture. They call them availability groups and all these failovers. But the point here is you could have, in this case, 9 different sets of machines. It looks like these may be multiple machines, and they're all participating to make sure that things don't fail. You've got coverage, you've got balancing, all the good stuff. You have to pay for licenses on machines based on how you're using them, what they are. Now, there's a whole sort of rubrics you have to go through. So I can't say that you would pay for all of them. They have passive, they have active clusters and passive and active machines, etc. So when you get into that, you may or may not owe money. And I want to be careful because I don't know. It would depend on the specifics. And in fact, that's what your official Microsoft licensing person would have to talk to you about. Well, is this active? Is it passive? Are you doing production work with it? But the point here is there's a lot more cost than that initial thing that we tend to think of. We tend to think of, I bought a car, I'm driving the car. You don't think of, I've got a car, but I need 30 backup cars, and I need 30 other cars to load balance if that car's not available. So you wouldn't think of, I'm going to pay for 30 cars. But when you think of SQL Server or any database instances, when you get into this failover, this high availability, you're talking additional machines and additional licenses, which means a lot more money. Okay, it's not for free. Nothing's for free. There's an economic lesson, thin soffle. There's no such thing as a free lunch, and this is where you learn that the hard way. So failover clustering, great. Obviously, one of the reasons these commercial database vendors have these things is partly because, hey, it gets you to use more licensing, and that makes more money. And balance loading, I should have said load balancing, but load balancing, again, multiple machines sharing a workload, obviously you're going to have to pay for those machines. Now, there's something else to consider, which is something I never thought of, because when I worked with databases, I never thought about it. But as I learn more about licensing, you don't just say, look, I'm going to buy SQL Server and I'm going to run it on that server. What are you going to charge me for that? And they give you a price and you're done. No, no, no. Actually, it's going to say that what they do is they say, well, how big are the cores in that? And I got 2 core. Okay, how many CPUs in that? Well, let's see. That's 12 CPUs. Oh, well, we charge you per, 4 CPUs, so you're going to have to pay 3 licenses per core. So now you're actually paying whatever their license is, 3 and then 3 to cover the 12. Then you get a new machine later on, and guess what? It's a powerful machine, more memory and more core, and that's got 32 CPUs. And so you're a 40 or whatever it is, and you could end up suddenly your price doubles unless you restrict it to what you originally started with, which means as the resources grow and the usage of your database grows to meet higher demands, your licensing costs go up too. And it's going to be variable. So it's really hard to nail that down. Microsoft has 2 sort of models they can use to figure out pricing, and obviously you would go with the cheaper. One of them is less focused on the CPU, but more focused on how many users. Again, if you're something like, large companies like, say, Verizon, which may have 100,000 users of a database, you could be in some pretty significant costs based on the user side of it, but then again on the consumption side also. So again, these are costs that I don't think everybody necessarily thinks of up front. And understanding licensing for SQL Server is it really is a discipline in itself. There's specialists that do that. It's not that simple. It's not a flat rate. Oh, and the other thing to understand is, like, maybe you're using different versions. So in SQL Server, again, I'll say this standard edition, which is much cheaper than enterprise, but also eliminates features. Some features it eliminates are actually performance related. So you're going to get slower performance, kind of like when when my iPhone, when Apple started downgrading the speed of your iPhone. Yeah, they don't do that hidden. They actually, SQL Server will not run as fast. It may not have some features. So you have to look and say, what features do you need? Standard is cheaper, but then all of a sudden you say, wow, that's a great feature. I had this happen at a customer. They wanted to use the master data services, and they have another one which is data quality services. And at the time, I don't know if it's truly the case now, but it required a enterprise license to use some of those more advanced BI features. Guess what? A lot more money. So do you really need it? So these are the things you have to be careful of, because again, you think, I'm buying SQL Server, I got everything, and these editions have very different things. Not to mention something called software assurance, which is a cost on top that has to relate to maintenance and what you get included in your licensing. So there's a lot of cost there, and licensing rules can change. So what you paid for today and you bought and you say, I'm licensed here, okay. But Microsoft or Oracle or anyone else can change the rules when you go to buy more things, right? So you might think you're okay and find out it gets more expensive as time goes on. That's the link for the getting information on licensing from SQL Server. By the way, I will put the link to the content for these slides. It's on GitHub. I'll put the link there. You can go get it and look at this and relive this wonderful presentation. But that's a big takeaway, and I don't want to underrate it. Obviously, commercial vendors want to, if you're only worried about cost and not other things, they want to play it down. But cost matters. You're in business to make money. And database costs are significant. These can get into the millions very easily for large companies. So you got to think about it. Let's talk about database services. Now I'm kind of extracting this. There are different types of database services these days, but the original database, the original relational database, supported core database functionality. I'm going to focus on that and then talk about other things. Core database functionality, something like Azure SQL Database, Azure SQL Database Managed Instance, is targeted at that. It's not targeted at any of the other services that you would get with with SQL Server on-premise. So it's something to watch out for. And so if you want those things, you're typically going to have to install SQL Server on-premise on a VM. Anyway, with Postgres, what do you get? Well, you've got a really good SQL language. This is ANSI SQL, and you get a procedural SQL. They call it PL/PgSQL, but it wouldn't look pretty there, so I just said PgSQL, PostgreSQL. That's the programming language of SQL, so you can write store procedures and functions, and a rich query language with Windows functions and all the things we know and love in the SQL language. You get a job scheduler. Not all databases have this, but they have one called pgAgent, which is a pretty good GUI interface, right? And you get that. And you also, of course, get the PgAdmin, which gives you the GUI to interact with your database. You're able to get to external data using foreign data and foreign data wrappers. You have good security, a lot of rich features around that, and encryption, that's great, and high availability features. So that's your core database functionality, which means it's actually targeted mostly at OLTP, online transaction processing. What about ETL? Well, there's no separate thing. So if you've heard of something called SQL Server Integration Services, it's a nice service. It is a separate service that comes with SQL Server on-premise, and I believe it comes with standard and enterprise, so it's good. It's very rich. It's very powerful. It's complete programming and use Visual Studio with it. Great. When I did my contract, I found I was able to write functions. They didn't have stored procedures, but I wrote functions, and I was able to use that with foreign data wrappers to get my data massaged clean and do everything I needed to do. It works. And most of the time when people even use it in other databases like SQL Server, they're using stored procedures to do 90%, if not all of it anyway. So I think you're all right there. Now, you can turn on and enable and install Python language support in the database. So you can write functions and procedures with Python. However, my reading of this, I have not used it, and I don't recommend it because I think the security risks are just too high. The problem with it is you can't restrict what Python can do if it's installed by the database security. In other words, you can't say, Brian can't read anything external on the hard drive. Brian can't do this. There's no sort of administration. You're kind of giving somebody superpowers in the database. And just to enable somebody to have Python access, the recommendations I've seen, and I think it's required, but is to give them super user authority. So you're right there, you're really opening up a Pandora's box. So I don't recommend it. However, what I do recommend is the last bullet there, which is external Python scripts. You can put Python scripts, on a folder in a drive, and these can be robust ETL processes, which you can execute through pgAgent. And now you really have the best of both worlds because there's great support with pandas, with Python functions, libraries, all kinds of good stuff. There's SQL Alchemy and all kinds of stuff you can use. So you can get ETL support. Now I am biased towards the data warehousing. If you know my videos, that's kind of my thing. If you're using something like a web app, this is less of an issue to you. But it's very important for data warehousing, business and analytics, etc. The other thing I would say take a look at, I want to take a look at more, may do some videos on this, but there's open source projects called Apache Airflow and one called NiFi. NiFi has been, I've heard of longer, I think it's been around longer. It's more of a traditional sort of ETL, scales well, and that's, again, Apache. The other one is Airflow, and seems to be a little bit like Azure Data Factory, but available open source, pipelines, workflows, etc. So those are good ones to look at as a way to extend Postgres, and they're free. open source, all that good stuff. So you can select. Open source is a bit of a smorgasbord these days. You can pick and choose what you want for tools. You just have to learn how to use them and integrate them. Now, what about machine learning? Now, I know, for instance, SQL Server has, in the Enterprise Edition, machine learning. It is not supported on their PaaS services. There's a preview edition, last I looked, to support our programming within the machine learning service on the Azure SQL DB, but I'm not sure where that stands. But if you're looking for that, then you're going to have to look for some sort of third-party extensions. There's open source free versions of things typically, and then there's commercial ones you have to pay something for. Again, this is a database which is sort of Python's own favorite database. So using Python with Postgres is going to be easy, and so I'm not sure it's really that critical. You can do that anyway. And if you're brave enough, you can always turn on Python internally, and then you've got a robust engine right within your SQL database. Finally, again, very popular these days is analysis and visualization of data. It used to be you had tabular reports, and they weren't very exciting, and so people wanted something more pretty with pie charts and graphs, etc. To do that, you typically use a type of storage which is not your traditional what they call row store. It's rows access. You use something called a column store. Analysis Services, I've done some videos on, is a really powerful version of a column store database and is offered as part of Enterprise Services, Enterprise SQL Server. Postgres is behind the curve on this because I've even seen stuff in MySQL supporting it, but there is a project called Project Z, and look it up. There's stuff they're talking about. I don't think I think it's still sort of under development, and you can probably preview some things. It doesn't seem to be completely available, but column store is compressed data. It pivots it. It's going column by column. It's much more efficient and faster to do slicing and dicing of data. So you can take a look at that. It's not the best story right now for Postgres, but I think there's ways around it, and you can use other services. In fact, if you're really looking for that, just use another third-party service. You can always use Postgres, and then if you're using, for instance, Azure Analysis Services. Love that service. Azure Analysis Services is awesome. Loving it. So you can look at that. It's a great service, and it's a pay-as-you-go. Also, I don't want to leave out PostGIS because it's a great service, and if you're focused particularly on geographical types of things, a lot of companies are, then that's a great thing you get out of the box. Separate, but you can install and free. The other thing I would say take a look at is something called Apache Arrow. Arrow I cover actually in my book, but I talk a lot about it for using it with Spark because sometimes when you're running functions on the Spark cluster, which means multiple nodes running concurrently, the data storage format has to keep marshalling data between them or reformatting data when it passes from Python, local data frames, into the engine, etc. And the same with R. Arrow gets rid of that. What Arrow does is it uses a very powerful in-memory storage format that it can use that's common. So once you get the Arrow storage format in place, all the different languages and tools can just use that, and it's generally better than what they were using, so it's a step up. Fortunately, Postgres has something called Arrow Foreign Data Wrapper. So guess what? You can just extend Postgres with Arrow, and you've got really good, probably the best you could get in terms of slicing and dicing, and you'll be compatible with a lot of other products. So take a look at that as well. Also want to mention Dask. Dask is a open source. I don't know if there's a commercial paid version, but I saw the open source for visualizations, etc. And honestly, again, Python, why not use Python and do all sorts of stuff with that? Because you've got Dash is a free version of that, which is for Python integration to do like websites and stuff with analytics. There's just so much out there. I'm a big proponent of using Python for a lot of things. You have to get people skilled on Python, but sky's the limit once you have it. So weaknesses. Ugh, I dread talking about weaknesses. It's great, there's no weaknesses. No, everything has weaknesses. So let's take a look. First of all, I've already talked about it, but it's the lack of the non-OLT functionality. In other words, if you're not looking to do a website and banging away, you're looking more at data warehousing, analytics, then you can't just do one-stop shopping with Postgres. You're going to have to look at other things to extend it. Now, security is weird because I was reading up and I was really impressed with all the new features they've had. They've done a lot. But I have in my mind a video I saw on YouTube a couple of years ago where the speaker was talking about just the glaring holes in the security. And one of them was in particular Now this has been fixed. There's a newer enhanced version, but they talked about MD5 encryption for passwords. So I wasn't very excited about that. And I saw some posts on, I was Googling around posts about passwords being in clear text. One of the posts actually talked about people making, DBAs making changes to passwords and things, and the log recording in clear text the passwords. And unfortunately, people responding, well, oh yeah, it does that. You should just protect your logs, And I'm sorry, but that's not a great answer. Passwords should be very, handled, obviously, carefully. And I'm not really comfortable with that myself, even though, yes, you should restrict your logs. I don't think they should be in clear text. I don't know if they've ever changed that. But the point I want to make is, in particular with passwords, be careful that users are not just putting their passwords everywhere, because by default, Postgres uses a user password security model. That's it. That's what it uses. Not a big fan. SQL Server does something I really like, which is Windows authentication. And you can even do that, I think, well, I'm not sure on Azure. There's Azure stuff, but the thing I like about it is it says, well, Brian's already logged into Windows. I know Brian. I'm going to drop him in the database, and the security permissions he has will be assigned by the DBA, so he can do this, that, and the other thing. But I never give it a password. I don't have to get into that world. That means that I'm not typing something that could be hacked by somebody else. That's really good. SQL Server has a lot of really good encryption algorithms and things also to protect things. So around that area, you do have to be careful. If you were going to be moving from a SQL Server environment to Postgres to save money, just watch that area very carefully. And what I would suggest, plug for Microsoft here, I think that a really good solution is to use PostgreSQL on Azure or on AWS. I want to say that you can use it there because they offer similar features, because you could then use things like Azure Key Vault to put your credentials. So you'd never have to really expose credentials. You can use Azure Key Vault, and that allows you to hide these things that nobody can ever see the actual values, and then you can maintain them separately and log in. And I checked, and it's like it does support these things. So that's really cool. This is a way you can leverage cloud technologies with a free database service to get super cheap processing, right? With a nice database, and leverage the cloud security features to kind of make up for potential weaknesses that you may have in the database. There's no in-memory table support. Bummer. I mentioned Arrow, which can help with some of this. But if you're looking for more OLTP, in this case, in-memory tables, it's just not there. And I was, again, surprised. MySQL has already added some things in this area. But in Postgres, it's just not there. So sometimes you have transactions flying in on a website. And as a result, you don't want to have to keep thrashing the drives because you don't have time for that logging and that physical writing. So in-memory tables allow you to just push this table like current orders in memory, and then you kind of log it on the back end and worry about catching up later type thing. Can really speed things up. I hope they put this in just for that's kind of a weak spot. So be aware of it. The answer around it might be trying to cache tables, but I saw some blogs about that, and you have to kind of trick it into, if you're hitting tables a lot, it will eventually put them in the cache, which should also speed things up almost the same. Finally, what about support? Now, this is any open source. You're going to have the problem of you don't have a vendor there that's dying to sell you more things, so they send in all these third-party support. They'll come in and say, "We'll do anything. What do you need?" And they clear the things. I mean, that's one of the benefits of having this vendor behind you. So support can be an issue. The answer is you're saving so much on the database. Spend a few bucks maybe on a third-party support. Postgres has Enterprise DB, I think it's called, and they actually have distributions and they can provide, I believe, support. But there's third parties out there. Find somebody around there because that can be a key area if you're really looking for it. The other thing I was really surprised when I did my consulting was it's really hard to find Postgres DBAs. My theory, not validated, but my theory is that Postgres is such an easy database to set up and use, and it tends to be used by web apps and developers in smaller shops. As a result, honestly, I don't think they have the really respect for DBAs and the DBA purpose, which is security, always on availability, all the things I've talked about. They tend to be just, let's get it up there and get it moving. And oftentimes, developers just do horrible things in databases, not only non-secure, but just horrible performing things. They don't appreciate sometimes the nuances and things you really need to do to operate effectively in a database. So getting DBAs to do this is tricky. The company I was working for was searching for a DBA. I don't know if they ever found one, but I didn't even know anybody that would qualify as a Postgres DBA. It actually could be a really good area for either DBAs that are looking to cross over, looking for work. It wouldn't be difficult to cross over from any other database. And Postgres may be one of the few growing databases at this time. It seems like the market for them is growing. I cannot get solid numbers on market share, but Postgres is definitely getting more interest. Finally, if you stuck with me this far, thank you. I think it's worth it. I'm going to hopefully do more. Put comments in. Let me know what you think, because I want to do more on this. I'm really excited about Postgres. I think it's a great database. I really do. And obviously with Python, it's a no-brainer. It's such a great combination. Let me talk about use cases. Again, I mentioned it's ideal for online transaction processing, which means that it's really good for any kind of back-end to web and mobile apps. It's Django, as I mentioned, it's like instant. You have it like no effort whatsoever, and it's there, and you can run it on any cloud, so you're really good to go. It's also good for intra-company, and I hope I got the meaning right, but I'm thinking internally within a company, right, or between companies under an umbrella. Behind firewalls, etc., it's also good, right? It's internal, also a great place to use it. And as I mentioned, because of all the public cloud support, it's just so widely supported that it's ideal for that situation, because you get the best of both worlds, the cloud services and scalability and protection and security with a great database that's publicly free and available. It's also, as I mentioned, lost an interview over this one, but it's perfect for startups with constrained budgets. I don't know about you, but I spent a lot of money getting my daughter through Rochester University. If I were trying to cough up $50, $100, $200,000 for SQL Server licenses, wouldn't have happened. Not that I was coughing anything up anyway, other than paying them. But the point is, if you're on a constrained budget, it actually makes a lot of sense. You got to pay for things. You have to be able to cover your costs. And if the revenue stream coming into a company is just beginning, you probably can't afford to do that. It's also good, and this is really kind of back-ended, because for me now, I'm very big into data analytics and data science and all that stuff. And it's really a great store for this. I was reading a blog by Hadley Wickham, and he's sort of the R god, right? He's written many packages, including LeapIR and all these really powerful packages in R. And he surprised me, because he said, I would most often not use SQLite. I would favor to just use Postgres because it's free. I'll install it and I'll use that. I disagree with that as the default, especially for Python, because it's already there in Python. You're good to go. But it's a great persistent store when you do need better scalability, better speed. It's really good if you want to have a secure environment where you can sort of have team collaboration, right? So maybe you have 10 people and you're working on a data science team. Then I agree. Like, I would use it over SQLite if I'm trying to collaborate and share with more than one or two people. And I'm not looking to just take a file and email it. Here, take a look at this. It's more scalable. It's more like a team collaboration. Postgres is great. It's a little more work to administer than SQLite, but it has a lot of functionality that's great for team collaboration. And for any applications that it doesn't seem to fit well, take a look. As I mentioned, it's very extensible, so there's lots of tools and extensions and things you can get that work with it. And of course, with Python, there's almost nothing that's not possible. And finally, I added this at the end because I was like, also, if you're looking to learn about data engineering and analytics and just anything, SQL is by far the most common used data language out there. It's not going away anytime soon. It's actually growing in use. So you can learn about it. Install Postgres and you can learn all about database management systems, performance tuning, how to use SQL, how to write store procedures and functions, and it's free. So this is a good place to go also for just learning. Okay, a little bit of a demo. It's not a lot of a demo here, but I hate to not do any. You can go to this link. Just Google PostgreSQL. Honestly, I have a tough time with that name. The proper way to say it is either Postgres or PostgreSQL. All right, but if you go there, you can see the different environments. So Windows here, and you can go and download that, install it, and play around. Put comments in. If you have some trouble, there are a few glitches I ran into because I had problems getting the PgAdmin to show up because I had to change a switch in the registry. So if you hit that, let me know. I'll put a link there and talk to you about that. But generally, you probably won't, and it's here. So you can go install it there. So now I'm running. I put pgAdmin on my taskbar, but when you install, it will come up here, pgAdmin 4, or down below, it'll be in, this is Windows 10. It's going to show up under PostgreSQL, I'm under 13. I actually got the latest. I deinstalled the old version and went to 13, which is at this time the latest version because I wanted all the latest features. Something else you can get is a sort of training database called DB Rental. You find it online and just install it. You can really just like attach to it, load it in. There's a feature you can import that, I should say. It's an import function, can load it in. And what you'll see when we look at this is we can see this is my default server, Postgres here, Postgres server, and then the database is under that. So I can have any number of databases under the server. And of course I can install multiple servers. And this is my database, DB Rental. You can see Postgres is the sort of default database you always get when you install it. And you can use that, or you can just create your own databases. And you can see, again, this is very SQL Server Management Studio like. It's a folder drop-down. It throws me a little bit, though, because it goes into, to get to tables, I have to go to schemas. And then under schemas, I have to find tables. And then I'll see my tables here. So you can see that that's how it's at. Now, schemas are, to me, they're really just a way of grouping tables within a database. So I can say, oh, this is my human resources. This is my finance area. So it actually becomes a part of the table name or the prefix to it. You'd say something like finance dot, accounting table or something. So the idea is a way of grouping things. In SQL Server, the default schema is DBO. In Postgres, it's public. And you don't normally have to think much about the schemas. You just use them. But if you have custom schemas, you can create them very easily. I like to do that. I'll, for instance, create a staging schema when I'm doing ETL. Excuse me. So I'll say, create a schema for staging, and then I'll put all my stuff around that so I can tell what those tables and things are for. All right, so let's start by looking at tables. So we can look under here. We'll see our tables. We have an actor table, and we can see our columns, and we can, look at properties on anything by going in here. We can see the definition. It's an integer. We can see if there's constraints, and you'll see it's pretty nice visual. Fun fact: this whole thing, as far as I can tell, was all written in Python. You can tell because it's Python scripts and things around it. So this is written in Python. And it shows you just how powerful Python is. Plug for Python. Now what I can also do is go over here, and I can do things like here, like script, and I can say create script. And you'll see here it gives me the SQL code generated. Now this is something I use a lot in SQL Server Management Studio. So then I can cut and paste it, and if I wanted a table that was like a slightly different version, I can just change the name here to some other name and then create a table that's very similar with the same kind of properties. So that's pretty cool. So you can see there's all kinds of things. I can look at constraints, I can see indexes, all these rules around it, triggers, it supports all these things. So that's my database overall. What I also wanted to show you was, what about the code, Brian? How powerful is the coding? So let me take a look at this. I'll say create script. If I go create script, it should give me the creation script for this function. And you can see create or replace. Now this is really interesting. To be honest, SQL Server didn't support create or replace, so they'd use create or alter until like, I think 2017 or something. It was really late. See schema name, and then in this case, the function name. And as I mentioned, you can pass in parameters. So these are parameters coming in here. And then we can say, it's because it's a function, it returns something. Now, you'll always see this sort of language reference in stored procedures or functions because, again, it supports multiple languages. You can use Perl, you can use TCL, etc. So PL/SQL is the one we're using here, PgSQL. And you can see there's always also these things about the parallel and how you're running it. Then you define your body. And again, if you are familiar with writing like stored procedures and stuff, you'll say, yeah, this doesn't look much different, right? It's the same kind of thing. Begin your block of the actual code. You can do SQL statements galore, return things, all kinds of stuff. So that's functions. This is just the demo one I'm showing you. There unfortunately don't have any procedures here, probably because procedures is a syntax sugar that was added later. You also have materialized view. I don't have any to show you here, but materialized views are pretty cool because what they do is they're sort of just a convenience for extracting data, to be honest. You create a view, but instead of just leaving it as a view, you physically create a table behind it so that it's faster, which kind of defeats the view, but there are use cases where it just makes it easier than trying to create extract tables and Views just aren't cutting it. All right, so you can see a lot of cool things in here. You'll notice you got a rich environment here. You got query tools. You've got a dashboard properties. You have dashboards, pretty cool, right? I love graphs, great. Dependencies. You can see all kinds of stuff. Your file menu allows you to create different things. You can connect to databases. You've got all kinds of tools available, backup and restores. If you try to do like a restore, by the way, be careful. You may have some trouble. I had trouble getting this to work when I think I can do it. You have to be selecting a database. It wasn't working because it was pointing in the wrong place, and I had to go into the configurations file behind the scenes and fix it. So if you hit that, let me know in a comment, and I'll point you to the riveting link if I don't remember to post it in the description. All right, so that's kind of just a high-level view of PgAdmin. I'll probably be doing something down the road. Also, a little carryover from Postgres is the idea of table spaces. You don't see that in SQL Server. First time I ever saw it was the first database, the second actual database was from IBM created the whole idea of relational databases. EFCOD, IBM, they created the original. The first one that they created was called SQL DS. After that was their flagship product, DB2, which goes way back. And DB2 used table spaces. It was a way of sort of allocating the room for the table. But this was in a mainframe environment, followed through to Oracle. And Oracle was heavily copied by Postgres. So a little takeaway I will point out is when you look at Postgres, you'll find yourself, if you know Oracle and you know SQL Server, you'll say, wow, that's like SQL Server. Wow, that's like Oracle. My observation is that the early features of Postgres seem to be copying Oracle. And in the last 10 years or so, they've been copying SQL Server almost verbatim, like much more than Oracle. They seem to be looking much more towards SQL Server, which means you're going to feel familiarity on either side if you know it. I did mention also pgAgent, so I created this job under pgAgent, and if I go to properties, you can see, I've got a job here. It's enabled. You can have steps. I've got one step. This isn't a SQL job, so it's just code that will run on a schedule. I don't think I set up a schedule, but I can create a timer here. When do I want it to run, etc. Again, very nice to have. Kind of really a necessity in my mind. The idea of using Windows Scheduler for a database thing would be crazy. Not a fan of doing that. So I should have replaced that column heading. Where did we go? Let me review this. We talked about what is Postgres or PostgreSQL. Now originally it was just Postgres without the SQL, it was just S at the end. But when they added SQL support, which was later on, they wanted to emphasize that, hence the SQL. Not a very easy way to do the name. We talked about what it is though. Free, open source database, really robust, enterprise ready. If you're looking for an alternative to a commercial one, I highly recommend. I think it's a great one to take a look at. We talked about the strengths. There's a myriad of strengths around Postgres, so I like it a lot. It's particularly suited well for OLTP workloads. It's great for any kind of data analytics where you just need a persistent store. It's great for startups that want to save money and not have to pay for it. As I mentioned, it's now offered as a PaaS on the 3 major public clouds, so that's great. There's just a lot of really good features around it. Talked about weaknesses. The biggest weaknesses is that it is OLTP, and you're going to have to look for third-party solutions, something else, or extensions to do other types of functionality. The other thing is, although it has nice security features, I think I would be careful around that. If you're used to Oracle or SQL Server, you're going to want to look closely at how are you going to secure this, and how do you do it the way you've been doing it if you're used to things like that. Now you can, I don't know if I mentioned this, but there's a way to make Postgres use Windows authentication and integration if you're on Windows. Might be an option. I think the cloud is a good answer if you just want to make sure that you're avoiding that. Talked about use cases, which kind of comes down to this as well. It's good for learning. It's good for any kind of database things you need for transactional databases. It's good for data analysis. Can be good for data warehouses, but again, you're going to have to look for other tools. And those are the different areas you want to take a look at. I think that's it. So I want to thank you for watching. Please subscribe. Please like. Please share with your friends, trade, all that kind of stuff. Make people aware that I'm doing these videos. I hope they're helpful. I get excited about them. To be honest, I get excited about something, and then I get excited about sharing it with other people. Say, wow, isn't this cool? Because it's all a new toy to me. So until next time, I'm pulling for you. We're all in this together. Take care.